Thank you for joining this talk on meta app quality. So users no doubt care about quality. Let me share 3 stories with you. So first, my own personal experience on Facebook. On the phone, I click on the app icon. If that takes too long to start to the feed, then I'm going to background the app, or maybe I'll go to another app. In this situation, I'm dropping off at the top of that funnel. Now let me share a story about my wife, Sue. Let's say she quickly starts into Instagram. The first thing she likes to do is view stories at the top. She especially likes live streams for shopping and resellers. And she's told me about instances where that story status says it's live, but when she taps into it, the live stream actually already expired. Now she finds this a frustrating experience. Sometimes she'll leave the app and go directly to that seller's website. So Sue has dropped off the app, although a little bit later in the funnel. Furthermore, Sue has lost trust in the app too. Finally, let me share the story about my sister Lisa. She recently went on a trip with her friends, and she wants to post a photo album. So she's going to tag her friends, fun and sun. So in Facebook, at the top, she starts to compose her post. Then she's got a large photo gallery on her device, so she's scrolling and scrolling and scrolling to find that specific picture she wants to share. But the app crashes as she's scrolling. So she comes back into the app, tries this again, scrolls, crashes again. She does this one last time, a third and last time. Then she gives up on posting and drops off the app completely. So Lisa came into this app with a specific task in mind, and then when she dropped, it's near the end of that funnel, at the end of her intended activity, but she didn't get to complete that. Again, these users care about quality. And that's certainly true to me, Sue, and Lisa. You hear about user focus a lot, but how seriously are we about this? Well, I want to take you behind the scenes into our philosophy of putting the user at the center of our quality programs. I'll share our user focus has actually resulted in tangible, real business impact. Now, here's a powerful example of that impact I want to share with you. One of my proudest experiences was working on memory efficiency, and we delivered a fix that resulted in a 9-figure revenue win. So we're talking about over $100 million in revenue. So this highlight was featured at the company Q&A with Mark. And it was just an incredible moment for our team that's well celebrated. My name is Bruce Chhay, and I'm an engineering manager here at Meta. I support the Facebook performance, reliability, and efficiency teams. Again, users care about quality, and our research has backed that up. It's shown that quality is one of the most important ways to build user value and user trust. Experimentation and analysis has shown that quality is a lever for perception, engagement, and revenue. So by the end of this talk, you'll see why quality should be a business priority for you and how to methodically approach it. So to touch on key facets of scale of the Facebook app, first and foremost, of course, our users. We have 2 billion daily active users on Facebook. That is a large fraction of the world population. So you can use the Facebook app to build connections with people in communities, explore content, express yourself, and of course, you expect a trustworthy and high quality experience. In addition, user expectations evolve over time as the speed of devices and internet evolve. So to serve our 2 billion users, we have thousands of developers that work on our apps across many different product experiences. And every developer must be responsible for quality. We ship thousands of changes server-side, which roll out multiple times per day asynchronously. We ship through continuous integration and continuous deployments. We also ship thousands of changes in a mobile client release on a weekly basis. So today, I'm going to be talking about 3 things. 1, Meta's definition of quality at scale. 2, deep dive into a few quality domains such as crashes, correctness, and video quality. Finally, I'll share what we're working on next. So let's start with Meta's definition of mobile app quality. While I directly support the Facebook app, I collaborate closely with my partners across the family of apps. That includes Instagram, Messenger, WhatsApp, and more. So at a high level, the areas of quality that correlate the most with user engagement are performance, stability, and functional correctness. Performance consists of loading time latency and responsiveness. Latency includes application start, such as touching the app icon or resuming the app. It also includes inter-level screen navigation, for example, going to that marketplace screen from the newsfeed screen. It includes pagination loading, such as that spinning wheel when you reach the end of your feed. Now, in general, human perceived latency for loading content is roughly 1 to 3 seconds, but that depends on the product context too. And now responsiveness includes things like responding to touch events, and frame drops when scrolling. So another critical area of quality is stability. And stability reflects app availability in the foreground when you expect it. We measure this through crashes. Finally, we have correctness, which reflects the functionality of the product matching user expectations. Now, there are additional quality domains that matter to users, such as application size, device health like battery, and more. Here, I'm simplifying a bit, and I'm highlighting the quality domains that tend to impact users the most. That said, our definition of quality also depends on product experiences. For example, Facebook provides a lot of media, images, videos, and now video quality is a specific approach to that product experience. And other product experiences might be fundamentally different, such as text-oriented replies on the Threads app. So next, I'll cover a few of these domains in depth, specifically stability, correctness, and video quality. Stability is measured by crashes of the app in the foreground. Now, these crashes can result in immediate tangible pain. For example, users can't even open the app. We call this an insta crash internally. Or users cannot complete their intended activity at the moment when they want to. For example, creating a post or discovering new content. And now, not all crashes are created equal. For example, a crash while creating a post might be more impactful if you can't recover that content. Separately, users might experience more pain when they encounter a repeated crash that completely blocks that intended activity. And then there are the long-term effects that we need to consider. Our research shows that users remember crashes for several months. So crashes have long-term impact on perception of quality and brand. So even when you fix that crash, those users are still left with the feeling of poor stability. And our analysis also shows that crashes turn users off the application itself. In other words, we lose trust in buckets, but then we must rebuild slowly with drops. So our definition of crashes and stability includes ANRs, which stands for application not responding on Android, and then stalls on iOS. ANRs and stalls require additional focus because they are frequently difficult to fix due to lack of actionable diagnostics. So we've built custom telemetry for this approach. For example, main thread queue monitoring. Then we need to make the telemetry useful to our thousands of product developers. One helpful diagnostic has been the visualization of thread execution and their associated blockages. This can include things like disk I/O, CPU, waiting on other threads, priority inversion, and more. And now here are some ANR examples that we've encountered and addressed. Moving IPCs off the main thread, identifying blocked broadcast receivers, and then dispatching according to priority as we need to. The challenge here is that our app has many broadcast receivers and they're dynamically registered as well. And then some of them might even be listening to the same intent. So the Facebook app, again, has many product features, has many developers, and now we need additional diagnostics to identify these blocked receivers. That also helps inform us on what needs to be prioritized to start the app itself. In another example, we have a lot of services, especially near that startup point. And it's difficult to determine exactly which services are causing that ANR and which services need for the app to move forward in the startup path. So we structurally improve the async service interfaces and then improve diagnostics around ANRs at this early point of the app. Finally, in the stability domain, we have memory issues. And memory issues are even more technically complex. We have less or even zero diagnostics. On Android, we encounter Java memory leaks, native memory leaks, and low memory kills, or what we call LMKs. By the time an out-of-memory issue occurs, or an LMK occurs, we have very little or no relevant information to debug that. That memory leak could have originated in the previous screen. So again, we've built custom telemetry to approach this. And in general, we have object allocation tracking. Now for sudden memory spikes, we can also use heap profiling to identify that memory leak culprit. Gradual leaks are even more challenging. That's where we track object allocations over the life cycle of that process. But we have to be cautious here. This requires sampling and selective tracing because there's a high cost to this performance diagnostics. Also importantly, there's privacy of data that we need to work with. The second domain of quality I would like to share is functional correctness. Now, this is all about ensuring that the app behaves the way the users expect. One way of measuring functional correctness is through what we call rage shake. While in the app, shake your phone to report a bug. Now, go ahead and give it a try. So reporting a bug is high user intentionality, and that's usually a strong signal of user pain. And here's how we classify a rage shake. We use natural language processing for these user bug reports. We parse the diagnostics and apply labels to identify traits of a bug report. Then we use machine learning algorithms for classification. Now, this results in more tangible symptoms that we seek to fix. Here are some examples of symptoms. 1, I can't load my newsfeed, or 2, there's no audio in my reels. Now, some bug reports, they require additional interpretation, so we define a difference between objective and subjective bugs. Objective bugs occur when a product feature is actually broken. For example, when a user clicks the like button to react to a post, but that reaction actually fails to ever register. Now, objective bugs, they clearly represent feature regressions, and they're tangible signals that a fix is required. So prioritization, that really depends on whether a user flow is broken, how bad it is, but also there might be fit and finish issues that are reported to us as well. Now, subjective bugs, they occur when a user expects a different experience from that current design. For example, the user would prefer a follow button instead of a like button for some of the pages they're viewing. Or maybe they can't access a feature and they don't know why. Subjective bugs, they still represent user pain, but they're a little bit more ambiguous, so they require a deeper understanding of that user experience. Sometimes subjective bugs result in new features or redesign. So that said, we also aggregate reports and trends into a voice of the community report. Now, these are deep dives into product experiences and even cohorts of users. These serve as case studies to improve existing product experiences, and they help us build new product experiences for our users too. For example, this has resulted in improvements to ranking quality, monetization for creators, newsfeed loading, as I had previously mentioned, and of course, these long tail of fit and finish issues. So these bug reports, they can be imprecise and they might even lack volume on some surfaces. So that signal, it can be challenging to work with. The recommended approach is actually to have more instrumented diagnostics for user flows. This includes your success paths, your failure paths, and full funnel analysis. Telemetry and instrumented paths can really precisely identify 1, the magnitude of the issue for the users, and 2, more quickly root cause your issues themselves. So this will improve your time to mitigation. For paths that are not well instrumented, user bug reports can still be used, and you can consider it more as like a catch-all or fallback mechanism for detecting user pain. Now, in our last deep dive, I'll share about product-specific quality. Facebook serves a lot of images and videos. I specifically want to discuss video quality. To put this problem into perspective, here's a scale of videos on Facebook. We serve billions of hours watched per day, and then we store exabytes of video. Now, let's consider some of the challenges for video quality itself. We have different kinds of users. Some users are data constrained, and they have limited data plans, different access to Wi-Fi or internet. And of course, internally, our own network backbone has limited bandwidth. So we can't just deliver unbounded bytes to improve video quality. Next, there's a ceiling on playback quality, and that's generally bounded by the original upload quality of the video when it's created. Lastly, we need to think about visual quality, and visual quality can have diminishing returns due to physical device limitations. For example, not all devices support efficient codecs to play back at 1080p at 60 frames per second. We utilize an end-to-end approach for quality. And quality of experience is our internal terminology for representing quality through each and every stage of our video pipeline. That includes uploading the video, processing and encoding the video on the server side, and then playing back that video for the end users on their devices. For example, if we just examine the playback section, this means things like the playback success rate, latency to playback, and then rebuffering while you're watching that video. We utilize an adaptive bitrate mechanism to balance both video playback quality and network bandwidth. The adaptive bitrate algorithm is a risk-reward algorithm. So as a simplified example, let's say a video has 3 encoding lanes. We've got lower quality at 1 megabit per second. This might be pretty pixelated. Then we have moderate, maybe this has better resolution at 2 megabits per second. And then we have a high quality encoding of that same video. Now this is very high resolution, high frame rate, very smooth experience. Now let's consider the risk part of the algorithm. Let's say we're in the middle of playing a video. So we have first one segment that's been played, then we have one segment that's been downloaded, it's buffered but not yet played, and then we got this last segment of the video that's not yet downloaded at all. So for this last part of the not yet downloaded segment, we need to estimate, do we have the available bandwidth? And then we need to dynamically choose one of those encoding lanes. So we want to minimize the likelihood of encountering a video playback stall while we're downloading. So that stall, that experience for the end user, is a spinning circle that makes the user wait instead of playing a video. And our research has shown that stalls are a major barrier, and it causes users to bounce out of those video experiences. So we want to minimize the likelihood of that occurring. Then the reward part of the algorithm is really to maximize quality for the end users, which generally means being as close to the upload quality as the device supports. Now in practice, this adaptive bitrate approach has delivered improvements in engagement due to playback quality, while also reducing the network bandwidth costs. So this has really allowed us to maximize our ROI by 1, increasing impact, and 2, reducing our costs. So let me conclude here with this deep dive by revisiting what we stated at the beginning of the talk. Users care about quality. Now, in other words, if I were to restate this, we need to focus on the user. I know this might sound cliche, but we've really brought truth to this statement through a deep understanding of what matters to users and this methodical approach to quality. In addition, user expectations and devices will continue to change, and we need to evolve to keep our users happy. The stakes here are high. Stakes are very high for quality. We risk engagement, revenue, and losing users due to low quality experiences. Finally, I want to share what we're planning to do to scale quality at Meta. We will continue to invest in quality itself. So as we seek these sustainable approaches to quality, we find that we actually require a change in our culture. Accountability and ownership are absolutely critical at our scale. So my colleagues are all expected to dog food the app that they work on, report bugs, and fix bugs. Ultimately, we also want to minimize that leak-through rate from testing, verification, and dogfooding practices. In addition, we achieve scale through automation and tooling. This requires full lifecycle support for regression management. That's detection and alerting, escalation paths, remediation, quick remediation, and of course, prevention. We want to also empower our developers and make sure our product teams can be successful. This requires automated root cause analysis workflows. And then we need safe rollout mechanisms for things like code, configuration, and machine learning models. Finally, I want to mention that we want a learning process to build resilient systems. This is essentially turning a moment of failure into a moment of success. So I lead the Facebook postmortem process for analyzing major outages of our sites. And ultimately, we seek to fix these systemic problems. So we're scaled out across the org, and we're all tied by a common motivation, which is building reliable systems. A second major opportunity is building an ecosystem of quality. Now, we believe our mobile infrastructure and our framework should be highly performant and reliable out of the box. This includes our internal frameworks and open source frameworks too. Next, as part of the ecosystem, partnerships have been absolutely critical for us. For example, partnerships with Apple and Google. They support quality improvements upstream at the operating system level. In another example, we integrate the telemetry available on Google Play and Apple Diagnostics. These have been incredibly useful for fixing tough technical problems. So in closing, again, I would like to reiterate users care about quality. And of course, performance and reliability are high-stakes expectations, and they continue to be a business priority for us. Now, if this area sounds interesting to you, then I'd love to stay connected and continue the discussion with you. Thank you.